we are lucky here at the University of Kashmir to have with us Professor Virender S. Chauhan, a person of such a great eminence and stature, who is well known in the country for his scientific inventions and scientific discourses, not only of the topic which we are going to deliberate today, but overall his leadership in various institutions all over the country, including NAC. So we are so privileged to have you with us. In fact, our faculty, our students, our youth are so lucky to have interaction with you and to listen to you. Believe me, when I was a student of your age, we never had this opportunity to listen to, scientists of such repute. And you are so lucky that scientists are over here to interact with you. So take due advantage of it. Take due, advantage and interact, listen, be dedicated to for all these full 2 days, whoever will be the speaker. And I'm sure that this symposium will educate all our college and university students about the integration of genomics and proteomics in medical sciences as a molecular diagnostic tool, whatever has been said so far also. I'm happy that I can see a good number of participants from various colleges, especially girls. It's important for universities to expose young students to emerging scientific areas, and today's deliberations are very important. I'm sure they'll be very useful to all of you. The symposium will provide ample opportunity to the students to explore their careers in the genomics and diagnostics, and a huge opportunity to interact with the experts in the field. We should be very grateful to Sun Pharma for choosing our university for the collaboration. We extend our full support in future also whenever these types of programs are to be organized that are useful, scientifically for our faculty, for our students. As already some of the speakers have said, that CIRI is a very important research institute of our university, and very good scientific equipment, high-end scientific equipment is already placed there. And whatever activities are to be carried on there, university is open to have that in collaboration with any institute. I really congratulate CIRI and Sun Pharma Science Foundation for this important initiative. CIRI is emerging as a visible and vibrant research center in the UT of J&K University and in the country. CIRI in a very short span has done exceptionally well in every aspect, like infrastructure, grants, publications, outreach, students' trainings and collaborations. The Honorable President of India, Shrimati Draupadi Murmu, has appreciated the establishment CIRI and the Brain Gain initiative of the university. University of Kashmir is fully committed to provide all the necessary support for the growth and progress of CIRI. Given their advanced facilities and expertise, CIRI is capable to start a course in molecular diagnosis, as already Dr. Altaf said about it. We are at it, just trying to figure out the modalities. In line with advancements in the field, I would request Sun Pharma Science Foundation to help us in designing this course, which would increase the employability of our youth. University of Kashmir would provide every kind of support for such initiatives, and we would also like to have more such symposiums, workshops, and collaborations with Sun Pharma Science Foundation. I would request to have a hands-on training workshop on genomics and proteomics so that our students would get trained in these emerging areas. I would again like to thank Sun Pharma Science Foundation for choosing University of Kashmir as a collaborating institute. I was just going through the schedule of 2 days programs. Very important topics are going to be deliberated, and I am sure that our students are going to be benefited by it. Once again, thankful to Professor Virender S. Chauhan and his whole team for choosing University of Kashmir, and congratulations to Dr. Altaf and his team, to Siri, for organizing this particular program. I wish best of luck to the program, and I am sure that our young students will be benefited. Thank you very much.
When British left us, both higher education and medical health sort of didn't even exist. You had small private institutions. So both, and this, I was born in 1950. I've seen it go up and down like a sine wave, sometime money. So 70s, many more universities are open. 80s, 90s, many more medical colleges. And then in 23, we can stand up here and talk about having a multidisciplinary, state-of-the-art facility to solve problems of, I'll come to that in a minute. I think this is a remarkable speed and very fast growth. And when I see result of expansion of higher education right in front of me, trust me, this pleases me no end. So I'm very pleased, Hema, that you suggested we should come here. This is one of the very first time when we decided to come out of Delhi, and this trend will continue, and I dare say this, that if once your equipment in RRI and everything is established, I don't see why we should not have a hands-on, very high quality workshop in the same location, maybe a couple of years from now. So Altaf, you be ready, we'll be here again. Let me talk just 2 minutes about the subject. If one can make it sound, the scientists have had this problem with society. And this problem of science with society is nothing new. Sometimes it just takes diabolical proportions. For example, to say that we will understand every single problem of a hugely complex machine such as us, and our interaction with a hugely complex evolutionary world that is outside, which is full of life in the form of viruses, bacteria, parasites, and what have you. This, to me, as I speak for myself, to me this is a very large claim. And I think scientists have to be very careful, and especially those of you, and most of you, hopefully will carry forward a career in science. I think there has to be very careful thinking what is possible and what is not possible, and what is not possible, how to make it possible. But to run away with the narrative that if every protein-protein interaction can be understood, how proteins interact with DNAs and RNAs, etc. Maybe we won't be here, your children will be discussing this. But to me it sounds very complex. The other thing that has always bothered me about scientists, what I call scientists rightly so get very excited about tools when they come in their hand. I remember going for a conference in 1988 to Trieste. The ICGB was just being conceived, and people had started doing fairly decent quality of DNA sequencing. And you couldn't stop people from saying that in 10 years' time we will resolve every problem, just because we can sequence DNA slightly better than we used to do before. And then currently we will talk about proteomics tomorrow, when we have sophisticated mass spectrometry available. Mind you, when I did my PhD in Oxford, till late 70s, there was not a single mass spectrometer in one of the number one university in the world. So the science, not in India, generally has seen huge advancement. And I think scientists are rightly to be greatly excited. But there are many diseases that we know very well. And they have remained a challenge. We don't have a vaccine for tuberculosis. We can't analyze tuberculosis. Those of you who will work in the field, you'll find how difficult it is in 2023 with all the molecular diagnosis and all the excitement, how difficult it is to find out whether you have latent tuberculosis or not. In principle, it can be done, sure. It can be done. And I just hope it will be done. But as of now, as I speak with you, we don't have a vaccine for HIV. I'm not saying that we won't have solutions for this tomorrow, but HIV descended upon us in 1970s. So we are looking at 50 years of huge investment of every kind in trying to find a vaccine for HIV. So sometime, especially for the younger people, I would request you, when this field is growing very fast, at the end of genomics, you always find omics coming in, genomics, proteomics, transcriptomics, whatever. Personally, I feel it must have come from economics. Because there's so much of push and pull of the industry which makes equipment, which sells these things. I mean, in a country like US or in Europe, you have to sell your science. And that's my problem with the scientists helping. I don't want to give a long lecture. Maybe if a time I'll just get a slot and talk about this in detail. But the other thing is the accessing what science does. Normally we feel what is I'm going to tell you on this. Let's say COVID created huge amount of mental distress. And it's a problem looking at us. And I would urge proteomics and genomics people to solve it from us. Why 45% of young people are now mentally compromised? If it's a complex problem, let's solve it. I'm not sure to grip to this problem will be that easy, but the problem, there is no end of problems, right from finding a cure for sickle cell, which are monogenic diseases. There are many monogenic diseases we know for years. And if you live in Chhattisgarh in the Sahu family, you don't know what to do with it. Government doesn't know what to do with it. So we should keep our feet firmly on ground as scientists and should aim for sky. In between, if we land on a treetop, then I think we'll be very lucky. So that's the message I want you to read extensively. There's a huge amount of this field is growing very, very fast. But to say that tomorrow from bed type we'll do genomics and find our solution, that's my last point I want to make. Accessing what science tells us. It's so difficult, at least for me, to figure out what is going to be accessible. I speak on authority to tell you, MRI has been around for many, many years. It's a fantastic tool, diagnostic tool. It's not a molecular tool, it's the imaging tool. And you would think everybody can access MRI because MRI exists. In Africa, in Zimbabwe, right now, there's not a single functional MRI. So there will be issues like this. And very recently, so accessing what science tells us in the literature might be available. Where is the stem cell therapy today? I would love somebody to describe to me where is it today. You hear anecdotal, so science itself becomes very muddy. In fact, President Obama actually had to make a statement because there was a very big voice that the huge money, research money from NIH everywhere was diverted to genomics. So we had sequenced almost everything by 2005. You couldn't find parasites or bugs or things to look at to which haven't been sequenced. But the people who made sequencing machines became extremely rich, and they continue to be rich. So there is a huge amount to understand, which is really not science, but understanding of accessing. Last example, COVID-19 vaccines came out, and this will remain in the history of mankind. In 63 days, we had the first mRNA vaccine in the arms of human. I don't think that kind of records will be broken again. 63 days, a new vaccine on a platform mankind had never seen before. So the power of science is not something that I'm challenging. And the power of science is more than ever before.
We have entered an era where we try to understand the basic causes of disease. What the drawback in the genomics of a particular person is, which is the cause of the disease. And after understanding that, how we can recommend a medicine. As was told in the beginning, I have been actually involved in medicine, studies on medicine for the last almost 30 years. What I have learned during that tenure is that initial concept of medicine was simply a remedial measure. How we can overcome a disease by recommending sometimes herbal remedial measures, sometimes minerals, sometimes synthesized products to overcome diseases. And majority of the cases, the recovery was sometimes very fast, within the span of a couple of days. Sometimes it would take a lot of time, sometimes weeks, sometimes even months together. But with the advancement of science, people try to understand exactly what the basic cause of the disease is, where it gets initiated, and what initiation is reflective in the overall system of that particular person who is suffering from a disease. Is it inborn disease or it's induced disease? Consumption of something, or say sometimes accidental touch with a certain chemical or certain infected material, or sometimes getting bitten by an insect or a bird, or consuming some contaminated water. People were trying to understand what that causes in the system of that particular person who is suffering from a disease. Is that bite by an insect or that consumption of a contaminated water causing simply a disease, or is it altering the functioning of a system? And that understanding helps us to see what changes have occurred. What the scenario about 30 years ago was, what the scenario now is, we try to understand not simply what disease is, but what is the basic effect of that disease on the overall setup of a patient's functioning organs and systems of the body. When we talk about understanding genomics, it is technically what is the genetic setup of a man or a human being as a whole, and what are the alterations in that genetic setup which causes the disease. Initial was what the symptoms are on the body as a whole, of a system of a particular person suffering from a disease. Now we try to understand what the genetic setup's alteration is which is causing that disease. What genomics is reflective in the disease as such, or what are the causes which are reflective in the disease. And it may take some time to understand that for the youngsters, but now those who are in biotechnology, who are in biochemistry, who are in clinical biochemistry, they easily understand exactly what the causes of the upsets are, how the change in the systems are. We nowadays see that a doctor analyzes a patient and then asks him to conduct certain tests. And after receiving the report of those tests, makes recommendations of medicine, treatment, etc. That is not simply seeing what the organ is as it is, but what is the fundamental drawback of that system which is the cause of the disease. And this is reflective of the fact that during the last 3 or 4 decades, the advancement of medical sciences, advancement of biological sciences is so fast and so conclusive. We understand where the cause of the disease has started or initiated, and what is the impact of that disease on the system's functioning. And once we understand, we try to look what can be the remedy for that particular disease. And in this, obviously, the investments made or the hard work carried out by many people to understand the system as a whole, what the genomics is, what the proteomics is, what is the relationship between these two with the disease, how we can assess this and try to recommend remedial measures to overcome a disease. It in turn reflects that with every passing day, newer and newer findings are helping us to understand whole system, which is sometimes either inheriting some drawbacks from the parents or is getting infected or say altered during the development of that child or that adult in a community as such. And that is where the understanding of the causal factors and developing a remedial measure can help us to overcome almost all the diseases. As you all know, when the COVID spread, we were trying to understand what it is and what are the causal measures, and after understanding that, we tried to look for remedial measures. It took us some time, but now we find that almost throughout the world, control is almost, I cannot say 100%, but almost 100% control on this. That shows we have tried to understand what the genomic cause of that disease was and what could be the remedial measures. And that took us some time, of course. Millions of people got infected, many got killed, but that in turn induced in us a concept of understanding the causal factors, understanding the changes induced by those in our body system as a whole, and try to develop remedial measures. And now, we with pride can claim that we are one of the countries in the world where we have developed almost 90% plus control on that disease. And that's an achievement. And in that achievement, understanding the genomic concept is the backbone. And I hope during these 2 days, whatever deliberation, discussion, or the keynote addresses are actually delivered, the students will try to understand what the theme is of the genomics and how we can understand the causal factor of a disease and to try to develop a remedial measures. Otherwise, if we look at only what the medicine is all about, without bothering about what the impact of that medicine on our body is, we cannot be able to achieve the goals. It is better to understand the cause and try to see how we can develop remedies. And as was highly pointed out in the beginning, that the participation of the students is mandatory in such functions because they will actually carry with them a concept that we should not simply look at the remedy, but we should look at what are the fundamental causes of that disease and then try to see how we can overcome or try to modify that system. It is in such workshops, in such symposia, in such conferences, we try to separate a message that every finding can open up newer and newer goals, which can help us to overcome whatever problems are spreading at a speed at which developing control in short span of time is impossible. And such workshops, such discussions will actually enlighten us that as how to understand the causes and how to develop remedial measures for those. And such workshops, such symposia are the fundamental need throughout the world. As you can see, every year we see some new disease spreading, and that disease in turn forces us to see what the causes are, and after understanding the causes, develop remedial measures. So in such workshops, it will be better to send a message to the youngsters that it is the theme throughout the world to understand the causal factors and then see what are the ways with which we can be able to not only control but overcome this in future.
We are privileged today that Professor Chauhan is with us, and his guidance, his acumen, his research knowledge. I am hopeful, and not only hopeful, I am sure that his guidance to our young faculty in the CRI and in the biotechnology will go a long way to help in developing a good research base at University of Kashmir. We are grateful to him and also to the Professor Himlata that they have given an opportunity to University of Kashmir to collaborate in today's 2 days workshop or symposium at the University of Kashmir. And what Dr. Altaf has already told about the CRI at the University of Kashmir, And I am sure that today's topic on the genomics and the proteomics will definitely help our young and budding research scholars to upskill themselves for the research they are proposing to do or they are doing. Because when we know that particularly the role of genomics in the health sector in rather in future and in present times is enormous. Particularly, I was talking earlier also on some seminar, when we see particularly in the Muslim community, when we go for the close marriages, particularly the primary kin or the secondary kin marriages in the Muslim community, we see that it has been reported medically also that there are genetic deformities found in the newborn babies. And probably this molecular science of genomics and proteomics will definitely help in identifying the problems, particularly the health problems in the neonatal stage or the embryonic stage of a child, to overcome such deformities in the growth of a child. And we see that after the child is born with deformities, we see that it not only becomes an unproductive mouth in the society, but it also overburdens the parents to upbring such children. So I am hopeful that the science of genomics and proteomics will definitely go a long way to resolve such problems.
This foundation is an independent non-profit organization whose aim is to promote scientific endeavors in the country and reward excellence in medical and pharmaceutical sciences and identify sources of knowledge and expertise. One of the key activities of this foundation is to conduct scientific workshops and symposia in frontline areas of research and in medical sciences. The foundation has actually over the past many years conducted symposia and workshops largely in Delhi and of late in other cities too. About 6 months ago, when we had our governing council meeting, Professor Chauhan asked me to organize either a symposium or a workshop, and at that time I had just visited the University of Kashmir and I had visited the Interdisciplinary Center. I saw over here a vibrant community of faculty and students across all departments carrying out cutting-edge research in life sciences. I talked to Professor Chauhan and told him that this would be the choice of my venue, and he agreed to my request for holding a symposium over here. And so did when I contacted Professor Altaf and Javed. Both of them agreed. And this is the genesis of this symposium. So there was, in the beginning, we had a lot of debate on whether we should have a workshop, a very focused workshop, or a symposium. And we decided that if we have a very focused workshop, we will be catering to only about maximum 25 to 30 students where they'll be undergoing hands-on training. On the other hand, if we have a symposium and we invite a large number of college students, we expose this knowledge to greater number of students over here. And we converged on the topic. And we finally decided that we would have a symposium on molecular diagnostics, and we titled it Molecular Diagnostics in the Era of Genomics and Proteomics. And Altaf has already told you, the significance of having a molecular level diagnostic tool and how to have people trained, give them exposure to this area overall. So this was the genesis of this meeting, and we decided that we would have students from the university and students from the medical school and also students from neighboring colleges, all from Kashmir. We have speakers over these 2 days covering a range of contemporary topics in the area of genomics, proteomics, and also metabolomics.
The theme of this 2-day National Symposium, Molecular Diagnostics, is of immense importance to public health, because the healthcare system is fundamentally dependent on diagnostics. And accurate and precise diagnosis is important to develop effective and efficient treatment strategies. And in today's world, we see that the medical decision making is hugely dependent on diagnostics. So given the power and potential of molecular diagnostics in transforming healthcare, this is one of the emerging fields and has witnessed a lot of development and growth over the last decade. And as per some estimates, the Indian molecular diagnostic market stands at $950 million USD, and it is expected to reach 1.6 billion by 2030. So there is going to be a huge demand for molecular diagnostic professionals having expertise in genomics and proteomics. And we have all seen that how devastating the COVID-19 pandemic has been. And the COVID-19 pandemic has again highlighted the importance of this sector. And when we look at the Indian scenario, the molecular diagnostic market in India is at an exciting juncture with lot of opportunities and for progress and innovations. But when we look around, there is a huge deficit of skilled professional molecular diagnostics with expertise in genomics and proteomics. And I believe that there is a need to have such courses at the university level. The Center for Interdisciplinary Research and Innovation, which was established by university in 2019 under the National Brain Gain Mission, was to uplift research and academics at the university level. And in a very short span of time, I'm happy to share that the CIRI has done exceptionally well in almost every aspect, whether it is grants, publications, student training, outreach programs, collaborations. And given the infrastructure and the human resource that CIRI has, I think it is in a very strong position to start a course on molecular diagnostics, which is going to have a huge impact in terms of adding skilled human resource, which will have better job prospects.